In this video, we're going to be talking about the graphs of the sine and cosine functions. So the graphs of both sine and cosine come from the unit circle. So whenever we graph something that's on the unit circle, any point here for whatever value of theta that I'm working with, it's going to have coordinates of cosine, comma, sine, for whatever angle theta that I'm working with. So if I was to actually plot those points along an x and y axis, it would give me two different curves, a sine curve and a cosine curve. So what you're looking at right now is my very high-tech attempt at failing, actually, at inserting a GIF or a video into this app. But what I have done is I have taken a video from my laptop, this is 2016. So what this is really going to show you in just a moment is how what we call in mathematics the unwrapping the unit circle function works. So let's say I have a unit circle here, and for every value of theta from 0 all the way to 2 pi, or 360 degrees, if I take theta and I take separate x and y values, so that means separating the cosine and the sine values for that theta, whether it's 0, 90, 270, 30, 45, whatever, and I actually plot that along my x and y axes, that's going to create two different curves, the cosine curve and the sine curve. So if you actually watch it unwrap, that's how we get these two curves here for sine and for cosine. And you can always Google this. I stole this straight from Wikipedia. So if you want to check it out on your own, I highly suggest that you do that. Now let's take a look at the sine function in a little bit more detail. So some things to know about any graph, or any trig graph, is that it has certain vocabulary that goes along with it. One thing to know is that the typical standard form of a sine function is y equals sine of x. Now we can manipulate that in a lot of ways, and we'll talk about that in just a moment. But something to know about both sine and cosine is that it has something called amplitude, which is its height. So that is always in absolute value. So another way to think about it is the absolute value of A. That is how tall the wave is from the x-axis. So it's always the absolute value because it's distance, it's height. So it's just its height from the x-axis. Notice that it also has a height of 1 down here as well. So another thing to know is something called the period. So that is how long it takes to complete one cycle. So a sine cycle starts at the origin, it goes up, it hits back down onto the x-axis, goes down and comes back up. This is one cycle. So the typical period of y equals sine of x is 2 pi. Now that can change, and we'll talk about that in a moment. Frequency tells us how many cycles the graph will complete in 2 pi. Typically it will complete 1, but again, that can change. So in domain and range, for standard is domain, all real numbers, it doesn't have any asymptotes, and the range typically goes from our positive 1 to negative 1. Now again, that can change as well. So another thing to know is that if you have sine, or the graph of sine in standard form, it's going to cross through the origin. And now taking a look at the cosine function, it has all of those vocabulary terms as well, but you may notice that it doesn't start here at the origin. It actually starts up here at 1. So if I have y equals cosine of x, I know how to tell it apart from y equals sine of x because sine will cross through the origin and cosine will start up here. Now that also can change as we manipulate the function, but its amplitude, just like the sine function, is 1. It is 1 unit away at its absolute height. Again, that is like the absolute value. Its period is also 2 pi, but it isn't quite the sine function where it will make a kind of S. It will make more of a U. So it will start up at 1, it will hit the x-axis, it will dip down to its lowest point, come back, hit up the x-axis, and then reach the same point that it starts at. So it makes this kind of like U shape. The frequency, again, is usually completes one cycle in 2 pi radians. That can change. Domain, all real numbers, just like sine. And the range as well, just like sine, goes from a positive 1 to negative 1. Now something else down here that's important is that sine and cosine look a heck of a lot alike. That's because one of them is shifted either to the left or the right of the other, but if you actually shifted it just enough and laid it on top of each other, both sine and cosine will become the same graph. Which makes sense because they're from the unit circle, and that has all sorts of relationships that we've looked at. Okay, so a way that we can change a function is we can put a number in front of the function here, where a would be, which would define our amplitude. So the standard sine and cosine graphs will have an amplitude of 1, but there's nothing stopping me from putting a 1/2 there, or a 5, and creating the amplitude of a 1/2 or 5 or whatever number you want it to be. Something else that happens is I could have a negative amplitude. So sine will always cross through here if the only thing I'm changing is my amplitude. It can change if I shift it. We're not going to talk about that right now. But my cosine, if it's negative, for example, if it's negative cosine, it'll actually start down here at -1 because the amplitude is negating itself. So it's not going to start up top at +1, it'll start down below at -1. And something else that can change is this b value right here. And that b value is actually the number of cycles that is completed from 0 to 2 pi. So we can also calculate the period from that, where it is the absolute value of 2 pi over b. So for example, if I looked at the regular y equals sine of x, the period is 2 pi over 1 or 2 pi. It completes that, this black line here, completes a regular sine cycle in 2 pi, or 1 cycle. But when I change this b value to be 1/2, 2 pi over 1/2 is 4 pi. So it doesn't even complete one full cycle of the sine curve. It kind of is backwards, but that's because we're dividing by a fraction, and that becomes multiplication. Conversely, if I multiply it by 2, I get 2 over 2 pi, and that gives me pi. So it will actually complete 2 cycles in the standard 0 to 2 pi, which is our blue line right here. Same thing with cos. So let's check out a few quick examples. If I'm asked to graph y equals 1/2 cosine of 3x on our standard domain of 0 to 2 pi, what I first want to do is I want to check out my amplitude. So my amplitude is that number right there. So my amplitude is 1/2, because remember it's always the absolute value, and that's also 1/2. And the period is going to be 2 pi over b, and this 3 is b, so that's 2 pi over 3. So it will complete one cycle in 2 pi over 3. So let's look at the graph. So as I check out my graph, the amplitude is 1/2. It's positive, so it is going to start up here on the positive y. It's going to create 1, 2, 3 cycles in our 0 to 2 pi, which is consistent with that. And it's going to take 2 pi over 3 to complete one of those cycles. Alright, so now let's look at y equals 3 sine of 1/2 of x. So first thing I'm going to do is I'm going to write my amplitude. So that's that number right there. Absolute value of 3 gives me 3, so it's going to have an amplitude of 3. And the period is going to be 2 pi over 1/2. And that is going to be like 2 times 2 over 1, so that's 4 pi. Now let's graph this. So looking at my graph, I noticed that it doesn't even complete a full sine cycle in our 0 to 2 pi, because this is a 1/2. And it literally tells me it's only going to complete half of a cycle from 0 to 2 pi, which means that its period, or how long it takes to complete that one cycle, is going to be 4 pi. So on my 0 to 2 pi, I'm only going to see half of that function.
And that's going to do it for this video. Have a nice day.